Hey everyone, welcome to today's video. In my lives, I built a procedural roulette wheel in Houdini for my thumbnails and for my short content. This roulette will display different ChatGPT personas, and the beauty of making it procedural is scalability. We can easily expand from 4 characters to 7, 8, or even 12 as needed. Now, let's start the build. We will start with a circle, and we can use the sliced arc in order to have it sliced like a roulette already. We will need a global divider, so we will make a little controller. Let's make a null object and change the shape to a circle because that's what I'm used to. And make it blue. Right, so we will add a parameter and it should be an integer. I'm so used at looking for floats that I always miss the integers. The name will be slices and let's put it at 6 at the moment. This number will be referenced a lot, so that's why I build it into a controller. Okay, we want our roulette to be a circle, so this is the minimal version, and we will just multiply until we have something that is close to a circle. I think 12 should be good enough. Yes, it looks like a circle. Now what I want to do is to define 6 groups that will be our slices. So we will do the group by range 12 because we multiplied by 12 out of 6. We will have to input a name. Yeah, this can do it, but I think having another attribute will be more convenient. And the attribute we want is simply the primitive number divided by this controller. So this is a prim rangle, and our attribute is slice. It's an integer. A at slice equals. So we will have to reference the controller in a parameter. Okay, I think this is correct. Oh no, we have to bring our multiplier, not the number of slices we have. So yeah, we will definitely add another parameter in there. It's another integer. And this one is the multiplier. Okay. So we set it to 12 here. We will copy that part and go there, and there we reference mult and not slice. Just to be exact, I will change the expression, destroy this parameter, and rebuild it. Okay, so now we have our slices. This is the first step. What I want to do is have circles on the slices that will hold the picture of the persona. We will need 6 points. We can start from the same circle, except that we will not multiply it. We need to find half the value of the angle of the slice. It will be 360 divided by, yes, and all of that should be divided by 2, I think. And let's check by changing the number of slices. Yes, cool. We will copy circles on those points, and we need the circles to be inside the slice. But first, let's only keep the points that we will use for the copy to point. We'll do it with add, delete geometry, but keep the points. And we will obviously remove the center. What's the best way to do it? I think I can just blast 0 because the center will always be 0. It's not working the way I expected. I need to think. I think this problem is more complicated than what it looks. Maybe we can simply make a parameter. Let's build the distance from center parameter. This time we need a float. We'll call it dist and label it. Let's copy the reference and paste it in there. Now we have this parameter that allows us to move the circles, which will make it a 2-slider procedural setup, not a 1-slider. Okay, so now if I want 6 slices, I can simply, oh, it's a 3-slider setup. Boo. You can do better than that. I think it's absolutely possible to reduce the number of sliders, but this involves some mathematical reflection, and I will just accept the fact that this is a 3-slider setup. So the fun part is over. Now extrude. I think we can simply have the circles on top of the slices. So I will remove this one and do that by match sizing. This probably needs to be extruded too, but just a tiny bit. Now let's move it on top. So it's on the Z that we want max to min. No, min to max. What? Oh, I'm max to max. We will need some, what's the name? Some little spikes right there to make the slowing down infrastructure visible. Now we can group by range. This time select one out of slices. So this is, I will call that slow, even if it's a terrible name. We have our points for the copy to points. We will just quickly do a little tube. The radius scale, it should be something like 0.04, I think. And caps, yes. Height 0.06. Yes. So it needs to be oriented in C for the copy to point to be correct. Let me check that the orientation is correct first. Looks like it is. Oh, I forgot to use the group. Slow. Yes. Oh, I took the wrong parameter. It should have been the multiplayer and not the slices. So the group is there just for the pleasure. Let's. Oh no, my colors are not procedural. We will do it in Vex quickly. So what we need is a primitive wrangle, and we need 3 random values. So float round R, because we will do random values with different seeds for each color and then set the color to the 3 random values. So this will be round G, this will be round B at CD equals set. We did it! So let's check that out. Still a multi-slider setup, but at least we have procedural colors. After this session, I did some research and found a way to do this much more elegant 1-slider setup. This second live implements it, along with a few modeling tweaks and basic lighting shading in Solaris. There have been some addition to the node tree. So this part of the tree is only the side of the roulette. I added bevels on most of the stuff that we had, so those little blockers have bevels now. I moved the poly extrude of the circles before the copy to point so that it's more easy to add UVs and also more easy to create groups. See, now we have a group for the face and a group for the rest. Right now, after the copy to point, I split between the faces and the backs, and then I name the back, and I did a little wrangle to name the slice by slices. So now if we look at the geometry spreadsheet, we can see that our faces have names. This will make it easy for applying texture within Solaris down the line. And after that, I do a little bit of cleanup on the geometry and merge everything together. And now we have the same roulette as last time, only with UVs and bevels. That's it. Last time, this was the state of the controller. We had the slice picker. I had this distance from the center slider. This distance is the key parameter for driving the circle size. It will be a function of the number of slices. That is something that I could have done the first time around, but I didn't realize that it was that easy. I only need to reference the distance from the center inside the radius of this circle and make 1, which is the big radius of the roulette, big R, minus this parameter. So now you'll notice that the circle will always be glued to the extreme limit of the roulette's side. So that's progress. But we also want to maximize the surface area of this circle. And for that, we need to do a little bit of trigonometry. So let's dive into Illustrator, where I set up a little walkthrough of the demonstration. I did quite a bit of research myself. It's an easy demonstration, but I'm a little rusty when it comes to trigonometry and mathematics. So I took a lot of roads and I was near the solution, but quite not at it. So I asked for a little help from ChatGPT. It obviously did find the solution pretty easily. This is a representation of the slice. So O is the center, B an extremity, and A another extremity. Big R is the radius of the roulette. We have the angle alpha. The whole circle is 2p radians, right? So alpha equals 2p divided by x. Now I will draw the bisectrix of this angle, and we will draw the inscribed circle. We know that for the circle to be maxed out, it has to be tangent to this arc and also tangent to the border of the slice. If it's bigger, it's not inscribed in the pie, and if it doesn't touch the sides, it's not the biggest possible. This 3 contact point circle is the biggest inscribed circle there is. This value is D, the distance from the center. It's the value we are after. It's very important. This distance is the radius of this small circle. D equals capital R minus lowercase r. By construction, a tangent is perpendicular to the radius. We know that this segment is also the small radius. It forms a square triangle that has D as an hypotenuse and R as an opposite side. From the trigonometric definition of sinus, we know that sinus of alpha divided by 2, this angle, equals the opposite side over the hypotenuse. It means that sinus of P divided by X equals R divided by D. So D equals R divided by sinus of P divided by X. Now that we have those two expressions, we can express lowercase r as a function of the capital R. At the end of the day, we have this expression, and if we have lowercase r, we have the distance from the center. Once we have that, how do we input everything back in Houdini? In HScript, sin expects the angle in degrees, so we have to convert it, because right now we're expressing the angle in radians. So this is the only little thing that we need to be aware of. The rest is the exact same thing, just written down in HScript. So now we can grab that and paste it inside Houdini, and magic should happen. Oops. Oh, that's funny. I changed the multiplier, so it's defaulted to 1. We have now the exact number of slices as sides to our setup, and that's not uninteresting, but that's not what we're after. I will paste the expression in the correct slot. It will be much better. And now you can see It's happening. We have the roulette, always with the circle maxed out. What we would like is some padding. I should simply do the padding on the radius of the circle. So let's just find a value that looks correct. I think I like that. Yeah, it's good. What we can do is go to Solaris. Let's import our geometry. So what I like to do is import it with force objects, because that way the display flag don't matter. Let's move the camera back. We'll probably need a slight angle to make it look a little better. Now, the materials. We will use metal shader for the border and the stops. We'll make it silver. We will need some kind of plastic white for the back of the faces, something pretty glossy. We'll build a placeholder for the faces. This will be the wheel. Add that to the base color. Okay, so now we have our materials. You can assign those on the geometry. You see why I did name the primitives inside SOPs? I have all my geometry within the roulette, but since it's named correctly, I can easily apply materials with the material linker. I want the silver to be on the picot, on the border. I want the wheel to... Oh, so I have... Yeah, okay. I have each slice named properly. I can do that. It's easier. And the same for the slices. And I can get rid of everything else. We will need to add some proper lighting on top of that. So this one is probably good enough for this scene. We can see that even if we divided the geometry quite a lot, you can feel the edges. So I will divide it a little more. Yes, it's better. Okay, so those colors are pretty ugly. If I take three colors, no matter how many slices I have, I will always get the possibility for a slice to be surrounded by two slices that do not share the same color. So we will use modulo to create that effect. We will go back to our Rango and change it. We want to divide a slice by 3. We can remove everything. Delete all spare parameters. Where is it? There it is. Color ID equals at slices modulo 3. I will check it as an attribute. So it's not a float, it's an integer. And now we can simply assign our colors to this color ID. If color ID equals 0 at CD call 1. So now we can do that twice again, except we will increment every section. Let's just check that everything is okay. 1, 2, 3, 4, 5, 6. Yes! This is so satisfying. Oh, this is unexpected. I thought that I would avoid this configuration completely, but it looks like I might have had the wrong idea. I guess that after every multiple of 3, you get this configuration. Yes, it's the case. Maybe I can have a wildcard as my primitive number 0. That should prevent the case. It's not very elegant, but I won't have the issue at least. I'm sure there is a super simple solution to that problem. If I come up with a more elegant solution, what I will do is, once I have a website, if I do a little blog post on this setup, I will add it later on in the blog post. We're far from it because I have a lot of stuff to do for this channel, but this is something that I will keep in mind. Let's do the wildcard. All right, so now this problem should no longer exist. Indeed, it doesn't. Now what we can do is quickly adding Grandma Lilith in the mix. Go to the material, faces. So we will first input the question mark. So this is an image. I think the tile image is more easy to handle than the other, but I might be wrong. Now we can see that our question mark is indeed there, but it's not correctly placed. So I will keep moving the UVs around. I know that's not the best way to do that, but that's the way I will do it on that video. Now we will add Grandma Lilith. We will duplicate this material. So those are question mark. You will be Lilith. So this one we will call the Lilith asset and move back to the material linker. So the rules, let's check out the rules. We want questions. Okay, and now we will just link Lilith to one of the faces. So face 0, let's choose this one. Yeah, we have Lilith, she's there. Awesome. That's it for this video. Thanks for watching. If you found it useful, please do the algorithm pleasing rituals, and I'll see you in the next one. Ciao.